In this video, I'll be taking us on JAMB 2026 series. Okay, now let's solve this question here. But before we solve this question here, we have to understand this question perfectly. Now they said a particle of mass 3.6 times 10 to the power minus 6 kg revolving around the Earth has a radial acceleration of 4.3 times 10 to the power 7 meters per second square. We are asked to calculate the centripetal force of the particle, and these are the options given to us here. Okay, now class, this video will review more on how to solve centripetal force. Of course, this word here, centripetal force, is a force in a circle that is an inward force. Okay, we have centripetal force, we have centrifugal force, though both of them are of the same formula, but centripetal force is positive, centrifugal force is negative. Please take note. Okay, so whenever you are given any question on physics, the first thing you have to do here is to list out the given parameters and apply the formula needed. If there's any condition, you can apply the condition. Okay, now let's first of all list out the given parameters here before we apply the formula. Okay, now the first parameters here, the first parameter, sorry, given to us is mass. Okay, the mass is given to us as 3.6 times 10 to the power minus 6 kg. The next parameter here given to us is radial acceleration. This word here is very important, not acceleration. They said radial acceleration. Please take note. Radial acceleration means circular acceleration. The word radial acceleration means circular acceleration. So circular acceleration or centripetal acceleration is given to us as 4.3 times 10 to the power 7 meters per second square. Okay, now we are asked to find centripetal force. Okay, let's list out the given parameters. Okay, given parameters, we have mass, and the mass here is 3.6 times 10 to the power minus 6 kg. There's no need for us to convert here. Please take notes. It's kg, not in gram. Okay, now the next one here given to us here is centripetal acceleration, that is radial acceleration. Either I call it radial acceleration or you call it centripetal acceleration. Okay, any acceleration in a circle is called radial acceleration, or you can also call it centripetal acceleration. Okay, so our centripetal acceleration here, that is AC, is given to us as 4.3 times 10 to the power 7 meter per second squared. Okay, of course, the radius of the earth here is also known, is a constant. Okay, the radius of the earth here is 6.3, though we might not use it though. 71 times 10 to the power 6 meter. Okay, so class, we are asked to find centripetal force. So let's write down the formula for centripetal force. The formula here is Fc is equal to class mv squared over r. Please take notes, where these letters here represent this mass here represent, this m here represents mass, v represents speed or velocity, r represents radius. Please take notes. But if you look into this question here, class, we have a mass. Of course, we replace our mass here. We don't have velocity here, we have radius. Okay, and there's no other way to solve for velocity because acceleration is already given to us here. This is acceleration, or we call it centripetal acceleration. Not only acceleration, it's called a radial acceleration or centripetal acceleration. Class, there's a formula we know before now that F is equal to ma. Do you remember this formula here? And then F is force, of course, but not centripetal force. That's this formula is for linear force. Y, m is mass, a is acceleration. What does it mean here? Let's compare this one here, this formula here, to this one here, okay? It means that if this position here is force, okay, this position here is mass. It means that this particular position here is going to take acceleration. That is, this one here will be acceleration. But this one here is for linear acceleration, since this force is linear force. While this v square over r will be centripetal acceleration. So the whole of this guy here, v square over r, I'm going to have this to be fc. So v square over r is going to be m of a c. AC, okay? And the AC represents, the AC represents centripetal acceleration. So now let's replace our values here. So mass is 3.6 times 10 raised to the power of minus 6 times centripetal acceleration is 4.3 times 10 raised to the power of 7, okay? So when you point your calculator, class, how do we solve this? Number with times number, you times this number with this number, okay? So I will have this to be 15.48 times. So in terms of 10 raised to the power minus 6 and 10 raised to the power 7, I will use the law of indices. If you have something like this, a raised to the power of m times a raised to the power of n, you take, when the bases are the same, you take only the one base and add up their powers, okay? So the same thing here, we have this to be 10, we have this to be 10. I will take only one here, this is going to be 10. Now add up their powers, this will be minus 6 plus 7, okay? Remember? So let's simplify this, class. Let's simplify this. I will have this to be 15.48 times minus 6 plus 7 will give us 1. That is 10 raised to the power of 1, okay? So representing this here in a perfect standard form, this is the same thing as, class, 1.548 times 10 raised to the power of 2, okay? But class, if you look into the option here, we don't have anything like 1.548 times 10 raised to the power of 2 here. Okay, if you look into the options here, if you look into the options here, we don't have anything like 1.5, okay? Okay, okay, we have, okay, we have. So this is going to be, the answer is going to be, approximate this is going to be equal to, class, 1.55 times 10 to the power of 2 in Newton. This is our answer here, okay? So class, to get more video on JAMB 2026, all you have to do, you hit the subscribe button to get more video, okay? Thank you.